Imagine you have the same amount of an ideal gas at two different pressures, pressure A and pressure B. So pressure A is lower than pressure B, and in the context of this video, the word ideal means that there is no attractive or repulsive forces between the particles that make up the gas. So if you measure the volume of this gas at, let's say, 200 degrees Celsius, the one under a higher pressure will have a smaller volume. If you try to measure this volume again, but this time at a lower temperature, like 0 degrees Celsius, the volume now is even smaller, but the one under a higher pressure is still the one that is smaller. The lower the temperature, the smaller the volume. And there is a direct relationship between temperature and volume. The higher the temperature, the higher the volume. The smaller the temperature, the smaller the volume. But there is a lower temperature limit for which it is no longer possible to measure the volume of a gas, because that lower temperature limit is when the gas becomes liquid, is when the gas condensates. Let's imagine we could keep lowering the temperature without the condensation of the gas to the point at which the gas would have no volume. So what temperature would that be? So that temperature would be negative 273.15 degrees Celsius or negative 459.67 degrees Fahrenheit. That is the lowest value the temperature can go. And you can see that regardless of the initial differences in pressure, if we extend the lines to zero volume, they all intercept at negative 273.15 degrees Celsius or negative 459.67 degrees Fahrenheit. This is absolute zero. This is the lowest attainable temperature.